Alright, welcome to your notes on Chapter 5, Section 3. We're talking about rate of change and slope today. And we've got some new vocabulary words. To start, our essential question is, why will the slope of any horizontal line be 0? And why will the slope of any vertical line be undefined or no slope? Alright, our first vocabulary word is rate of change. Alright, and the rate of change is a ratio. So that's a key word, ratio, that compares the amount of change in a dependent variable to the amount of change in the independent variable. In other words, the change in, let me get my pen there, the change in y over the change in x, okay? Because dependent is always y, independent is always x. Same thing as saying domain and range, okay? And we also have rise, run, and slope. So we continue. We've got the rise. Oops, I wrote rice instead of rise. Let me fix that for you. Okay, rise is the chain. Hang on. Alright, the change in y values between 2 points. In other words, how much did the line go up or down? And then your run is the opposite. It's the change in x values between 2 points. Alright. And then you have slope, which is just like what you think. It's like the slope of a mountain, the slope of stairs. The slope is any steepness that something has, any slant. The definition is a ratio, or actually let's make this better, it's the ratio. The ratio of rise to run. And slope is always written rise over run. You need to remember that for the rest of your math career. Rise over run. That is huge, really, really important. Big deal, big deal, big deal right here. Rise over run, rise over run, rise over run, rise over run. Always think of it like with a new baby. You know, think of the fact I've got a new baby. That baby's going to learn to rise up from a seated position before she's going to learn to run across the floor. So you've got to rise before you can run. Okay? So that's our vocabulary, and let's talk about how we apply this. Alright, let's do a couple of examples and show you how to use rise over run. Example number 1, we've got the table shows the volume of gasoline in a tank at different times. Find the rate of change for each time interval. During which time interval did the volume decrease the most? So I need to figure out between 0 and 1, 1 and 3, 3 and 6, 6 and 7. During which time interval did the volume decrease at the greatest rate? So from 0 to 1, it went down minus 3 gallons. From 9 to 5, or from hour 1 to hour 3, it went down 4. From hour 3 to hour 6, it went down another 4. And then from 6 to 7 it went down none. So that means that from 1 to 3 and 3 to 6 it went down 4, went down 4 gallons. Okay? Alright, and so that's all we do is we say the greatest rate. So the interval with the greatest volume, the greatest volume decrease was from hour 1 to hour 6. Let's do number 3. Need some graph paper for this one. It says, the table shows a person's heart rate over time. Graph the data to show the rates of change. We've got some pretty big numbers going on here, but they're all positive. So I'm only going to draw the first quadrant of my graph. But I think I'm going to count by maybe tens, because I have to go up pretty far here. So we're going to call this 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. 110, 120, 130, 140, 150. And then we're going up to 10, so in this case I can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so I'm going to graph, and remember, these are my x and these are my y. So I'm going to start with 0 and go up to 60. So 10, 20, 30, 40, 50, 60. It's at 0. Let me get a little different color going on here. So 0, 64, 10, 20, 30, 40, 50, 60. Oop. There we go. Done. Next one, 292, so that's 70, 80, 90, 92. And 546, 3, 4, 5, 146, 7, 10, 20, 30, 40, 50, 60, 70, 80, 84-ish. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, 20, 30, 40, 50, 60, 4. And there's the table. Okay, so we have various different slopes. We were going up, and then we came down really fast, and then we started going down kind of slow. That's how you work that one. Alright, let's try the next example. Alright, next we're going to learn how to calculate the slope. So remember, you have rise, which is how much it goes up. Run is how much it moves over. And slope is the change in y to the change in x. And so here's your equation. This is really important. Oops, that's kind of hard to see. Can't see through the highlighter. Okay, another way to write slope is going to be, or at least the formula to do the math, would be y2 minus y1 over x2 minus x1, where these numbers represent the second and the first y value. They don't have any sort of math value, they're just labels. Another thing you need to know is which slope is which. This was just like correlation when we were doing scatter plots. We have a positive slope, which looks just like when we had a positive correlation. We've got a negative slope, we have zero slope, and we have undefined or no slope. This is also known as no slope. But undefined is the most appropriate word. Okay? Now I want you to meet somebody to help you remember this. Or actually, before I have you meet somebody, I want you to see another one that I like to draw to help me remember. It's called Slope Mountain. You've got your mountain, which ends in a drop off of a cliff. See, it's a snow-covered mountain. And over here, you have a person skiing, or maybe they're skateboarding, and they're having a lot of fun. Alright, and it's taking work. Whew. It takes work for them to get up the mountain. It takes positive energy. Then when you're going down the mountain, it doesn't hardly require any work at all. You can just coast down. But then, you're just going straight. You have no work whatsoever because you have a zero slope. You're putting in zero force to move. Okay? And it's also zero fun. Going downhill is the fun part. And that was your negative slope because it takes negative work. This is your positive slope because it takes positive amount of work. Then when you fall off the edge of the cliff because you're not paying attention, you're having no fun whatsoever. I'm going to show you another example. This is a picture of Slopey Joe. Slopey Joe has an eye, looks like that, and then his other eyebrow looks like this. This is Slopey Joe. Notice he has a positive eyebrow. He has a negative eyebrow. He has a nose for no slope. And his mouth is shut, so he's not saying anything. So he has a zero slope for a mouth because he's got zero to say. Alright, so there's your other options.
Alright, so back to talking about slope. Sorry, I paused there for a second. I was getting a little tired last night, so I'm restarting this this morning. We were talking about slope. So what you want to remember about slope is you've got your positive, you've got your negative, your zero slope, and your undefined or no slope. Okay? And you have different pictures that you can help you remember. You've got Slope Mountain down here at the bottom. You've got your Slope Mountain. And then you've also got Slopey Joe, which is kind of like Sloppy Joe, but it's Slopey Joe. So whichever way helps you remember that you have positive, negative, no slope is the nose, and zero slope is your mouth. All right. So let's do a word problem. The Lookout Mountain Incline Railway in Chattanooga, Tennessee, is the steepest passenger railway in the world. A section of the railway has a slope of about 0.73. A slope of about 0.73. In this section, A vertical change of 1 unit corresponds to a horizontal change of what length? Okay, there it is. Okay, so remember, you have rise over run. Okay, and it wants to know what 1 unit of a vertical change of 1 corresponds with what length. So it wants to know if you have 1 on top, what's your run? Okay. Well, we know it's 0.73, so that's 73 hundredths. So I'm going to put 73 over 100, and then I need to reduce that down till I have a 1 on top. So for every 73 up, it's going to go over 100. Well, what happens if it went up 1? So to do this, you would divide 73 by 100, and you would end up with 0.73. Okay, so that means your rise would go up 1, and your run would be 0.73. Or in other words, it's not going to quite go over 1. It's going to go up 1 and then over almost 1, about 3/4, because 75 would be 3/4. So it's going to go up 1 and then over 0.73. And then up 1 and over 0.73. Okay? So that's what it would be. Good luck with your assignment. Don't forget to ask questions.